Hello, Math 2. This is Mrs. Bricky, and this is Unit 5, Lesson 3. We'll be solving some trig equations and talking a little bit about some trigonometry theory. So we worked on solving trig equations last time. This will feel very similar to what you worked on in class last time. We're just going to be working with context today. So this first problem, we have tallest building in the world is the Burj Khalifa in Dubai. So it's a very, very tall building. If you are standing on the bridge about 250 meters away from the bottom of the building, you have to look up at a 73-degree angle to see the top of the building. So we've got a 73-degree angle there. So our question that we want to answer is how tall is this building? So we want to figure out the height. I'm going to call that x on my little picture over here. So if we think about this triangle from the perspective of that 73-degree angle down here at the bottom at point C, this side that we're trying to calculate is called the opposite leg of the triangle. And the one that we know that we're 250 feet away from the base of the building. So this is the adjacent leg of that triangle. So whenever you are solving one of these trig problems, you want to think about which of your trig ratios should you use, the sine, the cosine, or the tangent. Well, for this problem, because our sides that are involved. We want to calculate the opposite and we know the adjacent. So we're going to be using a tangent ratio because the tangent ratio is the one that relates opposite and adjacent. So when we set up our trig equations, remember we start with our trig ratio. This one's a tangent ratio, and that ratio is dependent on or needs to have the angle in it. So the tangent of 73 degrees is equal to, for tangent, the ratio is opposite in the numerator and adjacent in the denominator. So this is x divided by 250. So we're solving this equation for x. So to get that x by itself, we need to multiply both sides of our equation by 250. That one cancels out. So in our calculator, we can calculate 250 times by the tangent of 73 degrees. So we get 817.7 meters is the height of that building. Very, very tall building. Just for some perspective, a meter is about the same length as a yard. So we're talking about like 8 football fields tall. So it's very, very tall. The actual true height of this building is 829.8 meters. So something to realize when you're doing calculations like this is that the level of precision that you use with your measurement can affect your answer. So we got a really close answer. Maybe this 250 wasn't measured very exactly, or perhaps the angle is actually like 73. Whoops, that's not a 7. Maybe the angle is actually like 73.2 degrees. And so we're just a teeny bit off because of the precision of our measurements. Pretty close though. Okay, this next example, Sam operates a conveyor belt machine that's used to haul materials to the top of a concrete mixing container. If the belt makes a 20-degree angle with horizontal and ends 40 feet above the ground, how far do the materials travel to get to the top of the conveyor belt, and how long is the conveyor belt? So if you're familiar with conveyor belts, or maybe you're not familiar with them, they look like this. They wrap around and they have gears on the sides that rotate the belt and carry the material up to the top. So our goal is to figure out how far the material travels. So that's our x value. Let's see, maybe this will show up better. So this is our x value, how far the material travels. We have that 20-degree angle down at the bottom, and we have the 40-foot height. So this 40 feet, that's our opposite side. None of my colors show up good on this. I'll just label it out here. That's the opposite side. And then the side that we're trying to calculate is the hypotenuse of the right triangle. So our trig ratios, sine, cosine, and tangent. Whoops, sorry. TOA, what am I doing? Our trig ratios, sine, cosine, and tangent, we got to figure out which of those we want to use here. Well, we know the opposite, and we want to calculate the hypotenuse, so we're going to use sine. The sine of 20 degrees, it's always the trig ratio with the angle, the trig function with the angle is equal to, for sine, we want opposite in the numerator and hypotenuse in the denominator. So this is the situation that's always a little bit more challenging for students to solve. We want to clear the denominator here, so we were going to multiply both sides by x. We're really always multiplying by what's in the denominator. On the right side, those two x's cancel each other out. So we have x multiplied by the sine of 20 degrees is equal to 40. And then we can divide by the sine of 20. And that sometimes feels very weird to people at first, but sine of 20 degrees is just a number and we can divide by it. And so now we're ready to type this into our calculator. We're going to type in, I am not spelling very well today, sorry. We're going to type in 40 over the sine of 20 degrees to get our final answer. It says round to the nearest whole number. So we would say that the length or the distance that the material travels to get to the top is 117 feet. So I rounded to the nearest whole number. Okay, we have a second little follow-up question here. It says, how long is the belt? Well, a conveyor belt, it has two sides that wrap around and then it has the wheels that turn it. So we really just need to multiply our answer by 2 to get the belt length. And I guess we're kind of neglecting, maybe a little bit of curvature right there on the belt, but this will be good enough for what we're doing. So if we double that or multiply it by 2, that's 234 feet. So the material travels 117 feet and the belt length is 234 feet. Okay, here's one. And, sometimes the most challenging part of these types of trig problems is that they don't always give you a little picture to use. This one gave us a picture with the triangle. This first one gave us a picture with the triangle. On this one, I do have a picture for you, but I haven't filled in any of the measurements. And on the next one, we don't have any picture to go by. So make sure that, one challenging part to think about and to practice and get better on is setting up the picture with the right triangles to help you solve your question. So this says you are sitting on a ledge 300 feet from a building. So this distance between you and the building is 300 feet. You have to look up 60 degrees. So you look up 60 degrees to see the top of the building. And you bring your eyes down 15 degrees to see the bottom of the building. And our question is, how tall is this building? So we're going to use two triangles to help us figure out this answer. We're going to use this triangle over here to figure out this portion of the height of the building. And then we're going to use this triangle over here to figure out this portion of the height of the building. And then our total height will be those two numbers added together. So I'm going to start with the green triangle. That green triangle has an adjacent side of 300, and we're trying to calculate the opposite side. So we're going to set up a little tangent equation because we want to calculate the opposite and we know the adjacent. So that's tangent ratio. So the tangent of 60 degrees, and a tangent ratio always has opposite in the numerator and adjacent in the denominator. So y over 300. So to solve for y, we just multiply both sides of the equation by 300. And we can use our calculator to evaluate 300 multiplied by the tangent of 60. So I got, calculator got, let's see, y equals 519.6. So that's sort of this upper part of the building. So to get the height, we need also to know this lower part over here. This is still a tangent. So the x is definitely opposite from the 15-degree angle. And this 300 is the adjacent to that 15-degree angle. So we're going to do another tangent equation. The tangent of 15 degrees is x over 300. So again, we're going to multiply by 300. And then we can use our calculator to make that calculation. 300 tangent 15 is 80.4. Well, the height of the building is just those two pieces added together. So 519.6 plus 80.4 means that the building is 600 feet tall. And that's our height, 600 feet in total. Okay, so one more of these word problems where we are doing a calculation of a distance. So this says from, and this scenario is a little bit tricky to set up a diagram for. Maybe you've been to the Grand Canyon, so this maybe will make sense to you, but the north rim of the canyon is higher than the south rim. So if we were looking at a cross section of the canyon, we would have this north rim, and then the canyon, has a river flowing through it. And then the south rim, it's not quite as tall. So this is our canyon walls, and we've got that river flowing through the canyon. Okay, so we've got a surveyor, and he is on the north rim. So it says, from a point on the north rim of the Grand Canyon, a surveyor measures an angle of depression. So an angle of depression is always that you're looking down. So we're looking down, he's looking down 1.2 degrees. And from an aerial photograph, he determined that the horizontal distance is 9.68 miles between where he is at and the point on the south rim that he is surveying to. So our goal is to figure out the vertical distance between his location and the survey point. So how much higher is he than that point on the south rim, knowing that it's a 1.2 degree angle of depression? So you can see our right triangle is set up there. From our 1.2 degree angle, this x is the opposite leg, and the 9.68 is the adjacent leg. So if we set up our trig equation, we're using a tangent again. And we do often use tangents for word problems. Not all the time, but a lot of the time we use a tangent ratio. So the tangent of 1.2 degrees is equal to x over 9.68. So if we multiply both sides of our equation by 9.68, we will sort of get our answer. So we're going to use our calculator here. And I got 0.202767. So that is in miles. It's 0.202766 miles. It does ask us for our distance. What is the vertical distance to the nearest foot? So it asks us to calculate in feet. So I've got the conversion factor right here. Every 1 mile is 5,280 feet. So to get our answer in terms of feet, we just need to multiply our answer by 5,280. Because there are 5,280 feet in each mile. So if we multiply by 5,280, we get that the surveyor is 1,071 feet higher than the point on the south rim. Okay, so if you have an assignment to work on, I would pause the video and work on that assignment, at least those first few problems. You should be able to do now that are in context. And then the second half of the lesson is about thinking a little bit more theoretically about trigonometry. So pause the video, do the first half of your assignment, and then come back and finish the video for the second half of the assignment. So I'm going to move on, but you pause if you want to. Okay, so here's a diagram of a right triangle. 5 is one leg, 12 is the other leg, and 13 is the hypotenuse. This is definitely a right triangle. We could verify it by checking out the Pythagorean theorem and making sure the Pythagorean theorem is true. But 5 squared plus 12 squared is equal to 169, and 13 squared is equal to 169. So this definitely is a right triangle. Another thing to notice is that angle A and angle B, because we're in a right triangle, those two angles together have to add up to 90 degrees. So we're going to first think about this triangle from the perspective of angle A. A is going to be our reference angle. So we're standing up here by angle A, and we want to know the sine, the cosine, and the tangent of angle A. Well, from the perspective of angle A, the opposite side of that triangle, the opposite leg, is 12. Sine is opposite over hypotenuse. And for this triangle, the hypotenuse is 13. So the sine of A is 12 over 13. The cosine of A is the adjacent over the hypotenuse, so that will be 5 over 13. Your sine and cosine should have the same denominator because they both have the hypotenuse as the denominator. For tangent of A, we need to do opposite over adjacent. So from angle A, the opposite side is 12, and the adjacent side is length 6. So the tangent of A is 12 over 5. Okay, so now we're going to change perspective. So we're not thinking about angle A anymore. Now we're thinking about angle B. So the sine of angle B, from B, the side that's length 5 is the opposite. So this would be 5 over 13. The hypotenuse doesn't change. It just is what it is. The cosine of B is adjacent over hypotenuse. So that'll be 12 over 13. And the tangent is opposite over adjacent. So that's going to be 5 over 12. So now that we have all these listed out in fraction form, let's think about if we notice some patterns. There's a few patterns you probably will notice. You might notice that 12 over 13 shows up twice. It shows up here and here. So that means that the sine of A is equal to the cosine of B. This is only true if A plus B is 90 degrees. They have to be complementary angles. But if you have complementary angles, then the sine of A is equal to the cosine of B. And that works here as well. Both of those are 5 over 13. Another thing you might notice is that the tangent of A and the tangent of B are reciprocals. This is one way of writing that. So the tangent of A is the reciprocal of the tangent of B. Now the reason that's true is because if you are at angle A, the side that you marked that's length 12 is the opposite side. So for angle A, that goes in the numerator. But if you're thinking about angle B, the side that's marked 12 is the adjacent. So for the tangent of B, the 12 is in the denominator. So basically, when you're switching angles, you're just switching perspectives. The hypotenuse doesn't change, but the opposite and the adjacent labels change to the other sides. And this idea of that the sine of A is equal to the cosine of B is true for complements. So here I have some information about the sine of 31.9 degrees, and I want to know what's the value of the sine of 58.1 degrees and the tangent of 58.1 degrees. Well, 31.9 plus 58.1 is equal to 90. So these two angles are complementary. That means that the sine of 58.1 has to be the same as the cosine of 31.9. So this will be 28 over 53. And because 31.9 and 58.1 are complements, the tangent of 58.1 is just going to be the reciprocal of the tangent of 31.9. So the tangent of 58.1 is going to be 45 over 28. For the purpose of the video, I am skipping this problem. Okay, so one last idea. If you know just one of the trig ratios in a triangle, you actually have enough information to find any trig ratio for that triangle. So we can use a diagram and we can use the Pythagorean theorem to help us figure out the other ratios. So this example 7 says, for triangle DAB with right angle D, it is known that the sine of B is 3/7. What are the values of the cosine of B, the sine of A, and the tangent of A? Well, it says that D is the right angle, so I'm going to label this point D, and it gives me information about the sine of B, so I'm going to put B here. Now I could have chosen to put B at the top of the triangle. It's just my choice to put it at the bottom. The sine ratio for B is 3 over 7, so we can treat the 3 as if it is the opposite leg, and we can treat the 7 as if it is the hypotenuse. We don't know the size of this triangle, so we're just going to use those lengths that it gave us in that ratio form. The triangle could be length 6 and length 14, or it could be length 9 and length 21. We don't know how big it is, so we can just use the similar triangle that has a side of length 3 and length 7 because we're working with ratios here. All right, so we've got our diagram set up with our information that we know. That third angle at the top is going to be angle A. We want to write down the cosine of angle B. Well, cosine of angle B is adjacent over hypotenuse, and we know the hypotenuse right now is 7, but I don't have a number to put on top yet. So we are going to calculate. So we first draw the diagram, and now we're going to calculate the unknown side. And we're just going to use Pythagorean theorem here. So I'm going to call it x for a second. Leg squared plus other leg squared is equal to hypotenuse squared. So x squared is 7 squared minus 3 squared. So we subtract the 3 squared. 7 squared minus 3 squared is 40. So if I take the square root of 40, I get 2 root 10. So I just square rooted both sides of that equation. So this third side down at the bottom that I wasn't sure the length of before, it's length 2 root 10. So the cosine of angle B is the adjacent leg to angle B over the hypotenuse, which is 7. So my cosine of B is going to be 2 root 10 over 7. Sometimes these fractions might reduce, but sometimes they don't, and this one does not reduce. Okay, the next thing we're finding is the sine of angle A. Well, from the perspective of angle A, the opposite side is 2 root 10, and the hypotenuse is 7. So the sine of A is equal to the cosine of B. Well, that's true. So we could have used that fact if we realized before we wrote down our ratio. We could have used that to answer the question. But yeah, these two are going to be the same. Okay, our last one is to write down the tangent of A. Tangent of A is opposite over adjacent. Opposite from A is 2 root 10. Adjacent to A is the 3. So 2 root 10 over 3 is the tangent of A. And again, sometimes that fraction will reduce, but this one does not. Okay, one more of those just because that's complicated. So our first thing is to label up our diagram or make a diagram. It says that right angle is U, and it says the tangent of N is 3/4. Tangent is opposite over adjacent. So I've labeled the 3 on the opposite side from N and the 4 on the adjacent leg to N. So we need to calculate the third side. And we're just using Pythagorean theorem. So leg squared plus other leg squared equals hypotenuse squared. This is 25 is equal to x squared, so x is 5. This is a Pythagorean triple. It's a pretty common one. It's called a 3, 4, 5 triangle, and it has a right angle in it. All right, so we've got our third side labeled, and now we're ready to answer the questions. So our first question is cosine of n. Well, from the perspective of angle n, the cosine is adjacent over hypotenuse, so that is 4/5. It also asks us for the cosine of r. Well, the cosine of r, the cosine of r. R is the one at the top. I'm like, there's no r. R is the top. This is triangle run, so I didn't have it labeled yet. So the cosine of r is going to be the adjacent to r divided by the hypotenuse. Well, for angle r, adjacent is the 3. That's the one that's next to r. So the cosine of r is 3/5. And then finally, I'm asked about the tangent of r. And the tangent of r is going to use the opposite here. So that would be a 4/3. And, we really could have answered that one from the very beginning because we know the tangent of n is 3/4. So that means the tangent of r is going to be the reciprocal, which is 4/3. All right, so that should give you enough information to finish your assignment for 5.3. Let me or your teacher know if you have any questions. Thank you. Next time we'll be learning how to calculate angles.